So what we've been doing is we've been using areas under curves when we know the formula for the area of the shape. But we know that sometimes we're working with curves and we don't always know that formula. So there are other functions, other properties that we can learn to kind of tweak the information that we know. So by definition, an even function has symmetry about the y-axis, right? So let me move this up into the right area. And anytime I have an even function, the symmetry is based on the y-axis. So if you take a look at this graph that I have right here, if I break it down in the center, you notice that this side of the graph, if I were to sketch in the area and call this right here negative a, this other half is actually the same exact area. So what I can do is shade this side, and let's say since it's symmetrical, this is positive a. If I shade in this side right here, if someone were to give me the area from negative a to 0, which is right here, wouldn't that mean I also have the area for this side? And if I wanted the total area from negative a to positive a, I can just double what was given to me on this blue side. So this property up here tells us if I'm given half of the area, I can just double it to get the other half on the other side. Well, if you notice, an odd function is slightly different. An odd function also has symmetry. However, this symmetry is about the origin. So once again, let me put this up there. So I have symmetry about the origin for odd functions. And that's true right here. If I were to say this is negative a and this is positive a, if I'm to shade this region right here and I shade this region right here, since it's symmetrical, the area is the same. The only difference is this is below the x-axis, so this has a negative area. This is above the x-axis, which has a positive area. When I end up adding those, if they have the same number, we always know that they're going to cancel each other out and give us 0. So by using these two properties, if I know a function is even or a function is odd, I can actually still find the integrals by using our typical rules. So what we can do is we can draw a number line for this function and then fill in the information based on what's given to us in the graph. Let me fix that number line. Right here. Okay, so if I take a look at this, I can see that this is an even function. Because it's an even function, that means the values are exactly the same on the other side. So if I go from 0 to 3, here's 0 and here's 3, I'm going to type these out for you guys. If I go from 0 to 3, and let's say here's my 0, and here's my 3, this is telling me that, oops, This is telling me that from here to here, I have to be at -4, right? Since it's an even function, we know that the value is exactly the same on the opposite side. And this is where a -3 is. That means from here to here, I also have to be at -4. If I take a look at the other function, it says from -7 to 0, so here's -7. -7 all the way to 0 has to equal a +6. Is it a 6? Which means from 0 to +7, I also have to equal a +6. So let's use these 4 pieces of information to solve our integrals. The first one says I want to go from -3 to 0, and -3 to 0 is already in here for us, and our answer is -4. So it's the same idea as using a graph, but now we're using a number line. If we take a look at the next one, in order to get from -7 to -3, don't I need to split this up into, first I have to go from -7 to 0 plus 0, and we know inside is f of x. I'm just writing in our integrals. I go 0 to -3. Well, -7 to 0 we know is from here to here, which is a +6. And then I have to go from 0 to -3, which means my answer is -4, but since the direction changed, I have to change the sign to give me a +4, which gives me a total area of 10. Good. Let's go and do the next problem. I'll do it in blue just to keep our colors separate. In order to do this one, I first go from 7 to 0 plus 0 to 3. And if you notice, I have a coefficient here of 2. So in total, I have 2 parentheses. 7 to 0 is this side to here, which is 6, but I changed the direction, which means I have a -6. And then 0 to 3 is -6. And then 0 to 3 is a -4, which if I do my math, -6 minus 4 is -10 times that 2 gives me -20. Okay. And let's do this last one in green. If you notice, I go from -7 to 7, and I also have a 2 right here. So let's go ahead and split this up. I go from -7 to +7, f of x dx. Let's write in f of x plus the integral of -7 to 7 of 2 dx. We know from -7 to 0 is 6, and then from 0 to 7 is also 6 because of our rule. That gives us 6 plus 6 is 12. Plus, if I integrate 2, I get 2x. So I plug in my 7, I plug in my 1. I'm sorry, my -7. Sorry, that's a -7 right there. And I get 12 plus 2 times 7 is 14, minus 2 times -7 is -14, which gives me a plus 14 over here. So 14 plus 14 is 28, plus that 12, it's 28, 30, gives me an answer of 40. Good. So let's do the next problem, and since this one was an even function, the next one is going to be an odd one. So we're going to use the same strategy. First step is I'm going to create my number line and then use our properties to fill in these blanks. We notice this is an odd function, so the values are the same, but the signs are going to be different. So let's start with -4 to 0. -4 to 0 has a value of +6, which means from 0 to +4, this is going to be a -6. And then I see that 8 to -4, I'm sorry, yeah, 8 to -4 has a value of 3. So if we look at that, here's 8 all the way to -4 is a 3. But since I'm drawing this and we go from here to here, that we're going to say that that's actually a -3. Right? So I'm flipping this over and going from -4 to 8 instead to give me that -3. So that means if I go from -4 to -8, it has to be the opposite, which is going to be a +3. Okay? So let's go ahead and start filling in these numbers. When I go from 0 to 4, I see 0 to 4 has to be a -6, right? If I go from -8 to -4, since we're using symmetry, we see that this is a +3. When I go from -11 to +11, even though I don't have those numbers up here, since it's an odd function, I know that our symmetry tells us that on one side it's going to be positive, the other side is going to be negative with the same value. So we know that this is going to be 0. And this one right here we can break up. So I'm going to do the integral of 0 to 8 to f of x dx minus the integral of 0 to 8 x dx. Over here, I pull out my 2, and then I do my integrals, and I see 0 to 8 is the same as, well, actually, if you take a look at this, and I fill in my numbers, if I'm looking from 0 to 8, I notice that I have this piece as -6 and this piece as +6. So the last leg that's missing from this entire piece is a -3, because -4 to 8, the entire sum has to be -3. If this 6 cancels that -6, that means this leftover needs to be my -3. So if I look at this, from 0 to 8, I actually go -6 plus that -3, close my parentheses, and on this side I need to solve the integral, so it's x squared over 2, and this goes from 8 to 0. Good thing is, if I plug in 0, it cancels, so we're not even going to plug that in, and we get 2 times -9, which is -18, minus, I plug in 8 squared. 8 squared is 64. 64 divided by 2 is 32. So if I add this together, I get -50. Good. So if you remember the rules for even functions and the rules for odd functions, you can actually fill in the pieces to these different number lines. We'll practice this a little bit on Monday. Make sure you do your homework that will be collected so we can go over all the different pieces for average value. Thank you.